Hello. In this question, we're asked about a function who is described using a Taylor series. It's 12 plus 5 times the quantity of x minus 1 plus big O of x minus 1 quantity squared. All the terms after that are of the form x minus 1 squared or higher. And we're asked to look at this near x equals 1. That's why you see powers of x minus 1 in the Taylor series. Now let's look closely at what we're asked to evaluate. It's a limit. F of 1 plus h minus 12 all over h. What does that look like? Why are you asked to find that? First, let's just find it straightforward, and then we'll recognize that as something very special. Okay, so what is f of 1 plus h? Let's replace every x with 1 plus h. So when you have x minus 1 and you put in 1 plus h, the 1's cancel. And all those terms become just h's. Okay, so that's half the numerator. From that, you're supposed to subtract 12. Well, that's going to make that thing cancel. And then once you subtract the 12, you're left with something that all has h's in it. What are you going to do then? Factor out the h. When you factor out the h, then it cancels. You can cancel with the one that's in the denominator. What are you left with at that point? 5 plus the big O of h. Okay, you're doing a limit as h goes to 0. What is big O of h? What is that? It's a term that says basically I have terms that all have an h in them, or higher degree terms. You know, h squared, h cubed, they all have h in it, and h is going to 0. So all those terms are going to 0. The answer to the question is just 5. But we could have done this in under 10 seconds. This question could be answered in under 10 seconds. If you recognize what you're being asked to evaluate as a derivative, right? It has that feel to it. F of x plus h minus f of x all over h. It's a derivative. And so, specifically, it's the derivative at x equals 1. How do we know that 12 is the function's value at 1? Well, you can just put a 1 in. You can see that 12 is a value of 1 when x is equal to 1. We're being asked for the derivative at 1. But we recognize it as a Taylor series, expanded at x equals 1. So those numbers there give us everything we need. The function at 1 is 12. The derivative at 1 is 5. We're done. The derivative at 1 is 5. We're going to just answer this question in under 10 seconds if we knew to connect it with the derivative. That's it. My name is Nakia. You reach me at CalcCoach.com. Thank you for watching. Please like and subscribe, comment down below. I'll see you in the next video.